Hey everyone, welcome back. So today we're going to talk about periodic motion. So what is periodic motion? Periodic motion is motion that repeats itself at regular intervals, right? Lots of objects that we use and kind of don't consider maybe undergo periodic motion. For example, a clock, right? You know, every 60 seconds, that second hand's going to start a new minute. Every 60 minutes, that minute hand will start a new hour, and every 12 hours, that hour hand will start a new trip around the clock. On a grander scale, think about our own planet Earth, right? You know, every 24 hours, give or take, we're going to start a new trip around our axis, rotating or revolving around our axis. Every 365.25 days or so, we'll start a brand new trip around the sun. Okay? Another example would be a pendulum. You know that when it gets to here, it's going to swing over here, swing on back, and you can literally set a clock to it. That's the whole function of a grandfather clock. Okay? Now, speaking of pendulums, for example, how can you compare one pendulum to another pendulum? Right? Maybe they're moving in different ways, maybe they're doing this or that. Okay? Well, there are three main characteristics of periodic motion that we can use to describe, pendulum A versus pendulum B. Okay? Now, the first of those three characteristics is called the period. Now, there is no real order. I say first just because that's the first one I'm doing. Okay? The period. Okay? The period is defined as the time for one cycle. Okay? The time for one cycle. In other words, the period for our planet going around the sun is 365.25 days. That's an amount of time, right? The period for 1 minute is 60 seconds, right? It's an amount of time, right? So period is simply just a time, and that is measured in seconds, right? We always use that MKS, that meters, kilograms, seconds system. Okay. Now, another characteristic is the frequency. The frequency. Now, frequency is defined as the number of cycles in 1 second. So what does that mean? Okay, the number of cycles in 1 second. Well, that means how many times can that cycle occur, that back and forth kind of motion, in 1 second. Okay? Now that has a special unit. That's called the hertz. Okay? It's equal to 1/2, but we call it the hertz. If we're writing it in an equation, it's capital H, lowercase z. And the last characteristic is called the amplitude. Now, the amplitude is the maximum displacement from equilibrium. Okay? It's your maximum displacement from equilibrium. So if a pendulum here is at equilibrium, if I swing it up this way, that height difference from the object here to the object now up here, that's your amplitude. Okay? Now, you may notice by looking at these characteristics here that period and frequency use a lot of the same terminology. Time, cycle, cycle. Okay? That's because they are related. Okay? We have an equation that we can use to compare the two. Okay? So, first, let's just say that period, we're going to symbolize using the capital letter T. Okay? T for time, but we capitalize it just so we know that this period is a special kind of time. It's the amount of time for one cycle. So a cycle has to complete for it to be the period. It's not just some arbitrary time. Okay? Frequency has a symbol, and that is just a lowercase f. Okay, I always learned it with a kind of a fancy squiggly f. You can make it just a standard f. It doesn't matter as long as it's just a lowercase f. Okay, so period, time for one cycle, capital T. Frequency, number of cycles per second. That is your lowercase f. Okay. Now, you might be able to get this from their definitions. We have time per cycle versus cycle per time. So we can say that the period and the frequency are reciprocals of one another. Period equals 1 over frequency. On the flip side, we could say frequency equals 1 over period. Okay, they are reciprocals of one another. All right, so let's do a quick practice on that one. Okay, let's say I have a pendulum, and that pendulum's frequency is 10 hertz. Okay, I want to know the period of that pendulum. Well, I just plug it in my calculator. T equals 1 over F, okay, which we say is 1 over 10 hertz. Okay, and 1 over 10 is easy. I don't need a calculator for that one, but if it were a less easy number, you could just throw that in your calculator, and we get that the period is 1/10 of a second, or 0.1 seconds. Simple as that. A lot of times questions will ask you in kind of a different way. It's like, oh, a wave is crashing onto a beach every 3 seconds. Okay, so if one wave every 3 seconds, right, you can use your definitions of period and frequency to then figure out what they're going to figure out. They might ask you what the period of that system is, what's the frequency. Use those definitions, right? Period is time per cycle versus frequency, which is cycles per time.